Hello everyone, welcome to Engineering and Economy. Today we are going to discuss about investment decision making using net present value. So this is not an usual teaching like start with what is mean by net present value and tell the net present NPV theory, because this net present value theory is very famous in any economic courses, finance courses, any banking sectors. But my teaching way is that explaining the problem. Then because of this problem we are going to use some financial techniques. That financial technique is NPV technique, that is called net present value. So this teaching, this learning is very useful for any decision making, not only solar panel, solar PV related decision making, any decision making. If you want to invest money on, or you want to put the money on the bank and save it, or whatever, any construction building projects or any projects. If the project is taking 3-4 years time, I mean at least 3-4 years time, then this NPV technique is very useful, whether to take this project or reject this project. So that is at the end we will decide whether we want to take this project or reject this project. Okay, let's get into the discussion. So we last in this last video we learned about the cash flow about solar PV investment. So solar PV investment, we have a 25 years lifespan. So each year we have a cash flow. So now there's a question like because we know that $100 getting $100 today and receiving $100 next year is having less value. I mean, receiving $100 today is having more value than receiving the same $100 next year. That is called because of the currency depreciation. So that when that comes to play, imagine that we are getting $100 after 20 years. What is the value of $100? How we can understand, or we can measure that $100? So that is the problem we are facing. So to manage that problem, what we are doing here, we need to bring all the revenue to a present point. So in our cash flow, see the present point is here, the zero. We are investing all our money, like $50,000, what we discussing early from the last videos. So all the revenue, year 25, we are getting some dollars, like let's say $6,000. These $6,000, I want to bring all to my zeroth timeline. So zeroth timeline mean where I'm investing my $50,000. So all the cash flows I have to bring to same timeline. Actually, yes, same timeline, but we are choosing the zeroth timeline because where we are investing, let's say $50,000. In our last example, we are investing $50,000 here. So we are going to bring all the money, all the revenue to the current timeline. This is the technique. This is the technique. We need some technique to bring all the cash flow to the beginning of the project. Then only we can do some analysis. So it means what the value of $6,000 here we are receiving after 25 years. What is that the current value of that $6,000? So what is the current value of $6,000 which I'm going to receive after 25 years? So very easy. After 25 years, I'm going to receive $6,000. So equivalent to that amount, what is the current value? Today, what is the current value? So, okay, there is a reason why we need to bring all the revenue to the zeroth timeline. There's a timeline. Okay, zero timeline where I'm putting my $50,000. So that timeline I'm going to analyze this revenue. So let's get into the last summary of last video. So in this last video, we um, calculated the first year solar PV energy production for 50 kilowatt solar panel, 79,200. So this is the summary from the last video. And first year revenue is $7,920. So here the NPV technique is very simple. We can finish within 5 minutes, but the problem is solar PV calculation, output calculation is not that much easy because we are making a lot of assumptions. So that is very important. What are the assumptions we are making? So at the end of this video, maybe another new video, I will discuss about each assumption, what can go wrong if the assumptions are wrong, because entire design, entire NPV calculation and NPV value will go wrong if the assumption goes wrong, or the assumption not wrong. What I mean to say, in future things may change. The solar panels price may increase, interest rate may go high, climate because of climate change the temperature can goes, and the solar panels uh, export value may change. I mean the tariff will change. So look at here, quickly we can go that assumption. First thing, we take 20% as consider losses. Some designers take 25% as losses, and losses may go to even up to 30 percentage, 35 percentage, we don't know. But as a designer, we take the reasonable assumptions. And second assumption, I said like there is no maintenance cost, because this assumption I make it because to make this teaching easy. But in fact there is a maintenance cost. Maybe after 10 to 12 years we have to replace the inverter. I also didn't consider that to make this teaching much easy. So those are the small amount of money, maybe $4,000 or $5,000 you may have to spend it. Okay, let's wait, and we consider the 5.5 hours peak sun hours and 10 cents. So all these assumptions, we will come back all total seven number of assumption. So this is very important. We will come back to this slide later. Now we move on to net present value. So before moving into net present value, there's a one key financial parameter, that is discount rate. We need to understand what is discount rate. So discount rate means that the interest rate used to determine the present value of future cash flow. In simple term, it is the interest rate, average interest rate. So if you go detail, the Federal Reserve Bank always uh, tell that what the interest rate commercial banks should charge for the short-term loans. So this is economic, the financial indicators how the country is performing, what is the interest rate they are charging for the short-term loan. So this is one of the things. In simple term, you don't need to confuse with all these financial terms or anything. In a simple term, we can say discount rate is opportunity cost. Opportunity cost mean like if you don't invest in this $50,000 on solar PV, what you do? Simply, you may lend this money to someone, or you put this money to do a grocery business or some other business. So if you do other business, what the other business will get you uh, um, profit, I mean what percentage of return you may get. So it is easy to we always compare with a bank. If I don't do this solar PV business with $50,000, I can deposit this $50,000 in the bank. So if I deposit this 50,000 in the bank, what bank will provide? Maybe if it is Sri Lanka, they pay like 8, 9, 10 percentage interest if I put in a fixed deposit. So even other countries is different. So we are equating our opportunity with the what we are doing with the solar PV investment. So that is the discount rate. So now you can simply understand discount rate is a interest rate. Simply is a average interest rate. Average interest rate that you can get from a bank. Simple. So if you go and search on the Google, you can get it that in Australia we have a 3.2 percentage interest rate. That is the discount rate. This discount rate, it is a standard average. But you still even can 5 percentage from some other places. It's up to you. You can consider 5 percentage. But for this example, I'm going to consider 3.2 percent, because 3.2 percent is a guarantee. Like if you have $50,000, you can give it to bank. Bank will give 3.2 percentage. So something like that. Rather than investing on the solar PV, you can get the 3.2%. That is the discount rate. Okay. In India, that is 6.5 percentage. And in Sri Lanka, it is changing. It is quite confusing, but at the moment it is 10 percentage. So we take 10 percentage in Sri Lanka. So this you can understand easily what is a discount rate we are going to consider in this NPV calculation. So net present value in short we call NPV calculation. Okay, so this is a comparison. I put Singapore as well because I know about Singapore economy as well a little bit. So by comparing this, you can see that how the countries are performing as well. The well-performing countries, this discount rate is low, and the poor-performing countries, discount rate is high. This is the finance, but learning finance is not the objective today. So we are going to do investment decisions. Okay, so from our last video, we calculated what is the solar PV revenue generated every year. So this is from first year $7,920 up to it goes up to the year 25. My image is blocking here, so year 25. Okay, so now each, then we also consider the 5%, 0.5% degradation. You remember, if you uh, didn't watch, please go and watch the video. I share the link here. You can watch the video, the previous video. And with that degradation, every year degradation, the loss of performance of the solar panels, we got this value. So this is a very good cash flow diagram. So I prepared for you. So here easily you can see that what is a cash flow, different cash flow. We have 7,920 at the first year, and the last year 7022, and before that likewise you can. So this cash flow we can easily get from your Excel sheet. You can put it in the Excel sheet every year. What is the difference? 0.5% degradation. So at the beginning we are providing $50,000 investment, total investment. We didn't consider any maintenance or any additional cost occurs in the middle. Okay, so now the target is to bring all the cash flow to the zeroth level. We are going to bring every cash flow to the zeroth level. Okay, to do that, we have a financial equation. We say the equation which is well used in finance. Okay, someone found this equation. We don't need to worry about that. We are going to make use of it. It is not the purpose of memorizing the equation or giving too much importance to this equation. The purpose is we have a problem. The problem is we need to bring all the revenue to the zeroth timeline. How we can bring all the revenue to zeroth timeline? Using this equation. What this equation tells that present value equal to future value divided by 1 plus R. 1 plus R. R is your discount rate. This is your discount rate. I explained earlier, very important, discount rate. It is a simple interest rate. Interest rate for the loan. Simply you can understand. You don't need confused with any financial other terms. It's a simple interest rate for the loan. Okay, or you can simply understand the opportunity cost. If I don't do this business, what I lose. Okay. Okay, in Australia this is 3.2%. Okay, then n is number of period, like every year, like year 1 mean you are crossing 1 year, n become 1. Second year revenue, n become 2. Third year revenue, n become 3, because you start the project at 0th year. Project start at 0th year, and all the revenues comes. And future value, this is your revenue received in future. That is in the cash flow, your actual cash flow. This is your actual cash flow. Actual cash flow actually it is a predicted. We don't know, because it's a predicted cash flow, because we don't know. We are receiving after 20 years, after 20 years, we don't know exactly what is the cash flow, but we are predicting the cash flow with all that 7 assumptions. Okay, this is no need to be exactly true, but this is what we are predicting we will receive. Okay, move to the next. So here I put one simple example. If you want to calculate first year revenue we set 7,920 is your first year revenue, $7,920. If you want to bring that to the zeroth timeline, I mean net present value. What is the net NPV value? Present value, not the net present value. What is the present value for this first year revenue? So we put the future value. This is your 7,200. This is equal to 7,920. So I put this value here. And what is 1 plus R 0.032, because 3.2 percentage mean 3.2 divided by 100, it become 0.032. So that I put here, and so that become 7,674. This logically acceptable. You have to understand this. The 7,900 value become 7,600. It means like around 200 plus 7,900, 7,000, yeah, about little bit of 200 to $300 differences, okay, between. So it is acceptable. Like you're giving like 200 to $300 as a interest for the future value. If you are getting the loan, you have to pay that 200 $300. Okay, so this is, we bring the present. This is the present value of the first year revenue. It's very simple. Because why I'm keep explaining, because every books or other channels or any Google search, net present value technique, they teach like a difficult task. It's just we are going to bring the future revenue into the present timeline, just dividing 1 plus R to the power n. Whatever you are receiving at the future, that is divided by 1 plus R to the power n. R is your discount rate, n is number of years. If you are receiving after 5 years, it becomes 5. It becomes 5. If you are receiving after 6 years, it becomes 6. Very simple. Okay, then we move on. So what in this, this you can do it in the Excel, because I don't need to, I'm not sharing the Excel sheet because it waste of time. So this is your revenue, actual revenue, 7,900 first year, and 1 plus R, this is 1 plus R. So we calculate that, and so then the NPV value, 7,674. So each revenue, I converted the NPV value, net present value, for each revenue in the Excel sheet. You can do it simply 1 plus R to the power, because the present value equal to, simply again I'm writing future value divided by 1 plus R to the power n. So very simple. You can put this in one column, entire term, this in one column, and this become in one column. So this is your result. This is your result. This is the NPV. NPV, the present value, not NPV, it's a present value. It's a present value. NPV is net, is subtracting. I will tell you what is NPV later. It's a present value. But entire term we call is NPV, but this is a present value. Okay. Go to the next slide. So now we are coming to NPV, net present value. Net present value means net present value of cash inflows, present value of all cash outflow. Actually, we don't need to write net present value. We can write present value of all the cash inflows and present value. Some books they write net present value, no problem. So present value of all the inflow minus present value of all the outflows. So in this, we got in the Excel sheet, we got 128,000 in total present value. If you sum up all the revenue converted into the present value, you will get 128,131. It's a big money, but don't think it's too big, because we took a lot of assumptions. And what we invest, that is the your outflow. Outflow is your expenses. Simply outflow. This is your expense. It's a total expense, because total expense investment. Okay. So in simple term, I'm telling. So now NPV is 78,100. So this is your NPV. So this NPV is very good money, very big value. It means like you are putting $50,000, but you can get $78,131 more over the 25 years time. But this is not exactly true, because we took a lot of assumptions, 7 different assumptions. Okay, that in sensitivity analysis, we need to do different case studies, like worst case, what is the best case. This is called sensitive analysis. We'll come to that slide later. So now we are going to take a decision. Now, if you hire me as a consultant and you gave this project, then what is my decision? What is my advice? am I going to tell to take this project or not? Definitely, I'm going to tell you take this project, because if the NPV, net present values, NPV is greater than 0, you can accept the project. So our NPV is NPV equals 78,130, 151 or 31 or something. Okay, so this is a huge number. It is definitely greater than 0. So you can take the project. Definitely you can take the project. There's no confusion. And if NPV is less than 0, definitely reject the project. Now wait. Even first decision is to take the project, but if you are very smart investor, you're going to ask some more question like how this calculation conducted, how I come up with this 78,000, how I come up with 78,000 with all 7 assumptions, a lot of assumptions. So whether these assumptions are appropriate or in the future after 2 years, because now I took 3.2 percentage as interest discount rate. What happen if it's suddenly become 10 percentage in 5 years time? Because we assume this 3.2 percentage is going to continue for 25 years time. Similarly, we took like what is that? There's no maintenance cost and there's no inverter replacement. That's one assumption we took. But what happened if the panels failed in the middle and you ask the uh, suppliers or someone to come and replace the inverters and replace the assembly or something? It cost. And what if the climate change, because of the we assume 5.5 hours as the peak sun hour. What happened if because of the climate change suddenly temperature rises? Many people think that if temperature rises is good, but it is definitely bad for solar panels. Solar panels need more radiation with at 25 degrees Celsius. Moderate temperature, more solar radiation. But if the temperature increases, solar panel can get burnt. So those kind of things we didn't put into analysis, and mainly we put 20 percentage of for losses. And how we can ensure this is losses will be 20 percentage? What if loss become 25 percentage? What if loss become 30 percentage? Okay, so in this case, the first decision making is done. So we are clear with the first decision, that is definitely yes. Investing solar project will definitely give you a very good return. But the second thing is detailed study. This detailed study, we need to study the best case and worst case scenario. The best case scenario and the worst case scenario. Best case and worst case. This is one study, and the worst case. Worst case mean we are because it's a 25 years project. There are many things can happen. Now we assume the selling rate is 10 cents. What happened? Suddenly government says we can't pay 10 cents, we will pay only 5 cents. I mean half of the revenue is gone. This entire money become half. Simply, not exactly become half. It become more than half. So all these are uncertainties. So as an engineer, here is your role become more important, because a financial planner or financial advisor cannot do this kind of analysis. So you need to know simple decision making theory that is already done. We already completed how to make a decision. You find the net present value of all the revenue and find the net present value. If the net present value is greater than 0, yes, accept the project. But some other project, why I'm keep on talking, some other project, it is easy to find the accurate prices. Let's say maybe constructing a house, because you're going to build a house at least within a year. Maybe in the worst case you go within 2 years. Within 2 years you can build the house. So we are buying the land, building the house and selling it. You can finish entire project within 2 years. So within 2 years mean the interest rate barely not going to change. So there's a less chances of climate problems or disaster. So 2 years period is a small period. It's easy to find the easy to analyze what can go wrong. But 25 years is a long period. So in this 25 years period, whatever you make a design or that calculation estimated revenue, you have to question that estimated revenue. Re- uh, uh, will I get the estimated revenue? How likely I get this estimated revenue? Because we said that in the first year we will get $7,920, and the last at the 25th year something like 7,100 or something. So how likely at the year of 25th I will get $7,100? What if the entire solar panel failed at the 20th year? What if the entire solar panel burned at the year of 10th? So do you have a full insurance? All sort of things you have to analyze. What if the government uh, give very poor money? I mean the tariff change very low um, value only you can get by selling the whatever energy you generated at the year of 20 or 20 after 20. So all these come into a probability study. Now you getting into little deeper, like research kind of things, because these are probabilistic nature. Because how likely the government will reduce the buying rate of the uh, solar energy, solar what the power you are exporting. How likely government will increase the interest rate? How likely the solar panels will degrade more fast? We are taking 0.5 percentage as the degradation rate, but how likely that panel will uh, degrade faster? How likely your uh, temperature, and the world is heating now very fast. I mean, there are a lot of talk going on because of we really feel that temperature is going up. So how likely climate causes negative impact on the solar panels? Like suddenly the temperature become 30, 35, 40 degree every day, then solar panel performance will become too poor. So all this comes as under probabilistic study. Then as a decision making engineer, you're not only just doing the NPV calculation with net present value calculation, you have to put your probabilistic theory, some models, some modeling to fix these 7 variable. So at the beginning, I said there are 7 variable. Because of recording, I can't go back to the first slide. We took 7 different assumptions. So those assumptions are probabilistic in nature. So we are going to fix those. I mean, we are going to fix mean we are going to put our deep understanding on those 7 assumptions, and we are going to find what is the best case scenario, what is the worst case scenario, what is the average scenario. So by calculating, if our NPV value is positive even in the worst case scenario, then you can go for the in, project. But I am saying worst case scenario. What is the worst case scenario here? The 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 price become low, very low. We can judge how low it can go, the tariff or the buying price. The weather become bad, the climate become bad, how bad it can go, because we can analyze last 30 years weather data, how bad it can go. We can predict, and we can check how bad the losses will become. So these all comes prediction and probabilistic study and some mathematical model. With that some mathematical model we can do a little bit analysis how bad these things can go wrong. Even that bad situation, my investment is making positive net NPV, net present value, then yes, you can go for an investment. So very best example, in I think can I tell or not? Okay, in Sri Lanka, because it's everyone knows, like during the crisis time, I interest rate went to 22 percentage. I mean that this discount rate went more than 22 percentage. So even through my deposit, I get 22 percentage interest for about 5 lakhs deposit for 100 days deposit, because during the crisis time I deposit money and get 22 percentage. So should I invest in solar panel on that crisis time? If I invested that, I'm not talking the entire 25 years, last 1 year time. So last 1 year time, because of economic problems, the interest rate, the discount rate went too high. Even it went to 26, 27. So that particular year, uh, in that particular year, the banking deposit is much better than solar panel revenue. So What if this 22% now is luckily went come back to 10%? So luckily we are back to 10%. But what if this 22% continue for next 10 years? If it continue for next 10 years, we will definitely lose the investment. So our solar panel investment become a bad choice if in case the same 22% or something continue for 10 years or more years. So these all sort of discussion is it is a deep understanding or deep thinking. So as an investor, as an engineer, you have to concentrate on the factors affecting the solar panels output or energy production, and at the same time you had to analyze what is the financial things going on, how you can advise the investors to invest or not, and what are the challenges, what are the problems. Now a lot of inverters are increasing its lifespan. We don't need to replace the inverter in the year of 10, it can extend to year of 15, 16, 20. So there are a lot of research going on material aspects of the solar panel. So even if the temperature increases, solar panel will not affect. Without affecting, it can generate some amount of solar energy. So if the research is successful and they come up with a very good material, with a solar panel with a very good material that can generate output even at a higher temperature than this climate, because of the climate change we still um, unimpacted because of the increasing temperature. So these all things are under discussion. I mean, we need to discuss further in these kind of things. So at the moment, uh, I'll leave here. Please subscribe my channel and please subscribe my channel and provide your support so that I can um, give more this kind of prepare this kind of slides and share my knowledge, and that will be very helpful to you. So this is like one place you can learn most of the things, not just the one aspects, like a broader view. I always say it's a broader view, looking from A to Z what you can do. And okay, thank you very much. We'll meet you in the next video.